Throughout human history, fishermen have used netting to harvest food from the sea. For all but the last half-century, netting was made from natural materials that provided limited strength and durability and required constant maintenance. The introduction of synthetic fibers in the 1950s enabled gear builders to create much larger, stronger nets that were far more durable than their predecessors. Modern trawls, seines, and gill nets are carefully engineered cordage systems that permit efficient, high-volume production in commercial fishing operations. Netting is also used to create aquaculture cages, current or debris barriers, filters, screens, safety restraints, and other devices. While today's netting products are remarkably light, strong, and durable, they are systems that must be properly maintained to function efficiently. For example, these enormous Bering Sea trawls are engineered with precise geometries designed to maximize mouth area and fishing power. Well-maintained nets are essential for achieving efficient production with minimum damage to the environment. They are also subject to enormous wear and tear and must be frequently repaired on deck. A crew that can mend well can take full advantage of the opportunities on the fishing grounds. The fishing industry always has a job for a good netman who can quickly repair damage and get the gear back in the water. This program is intended primarily as a practical guide for fishermen who want to improve their net mending skills. Because the techniques used for repairing fishing nets are common to most netting systems, the same information can be used by virtually anyone who utilizes netting products. The best way to use this program is to pause it frequently and practice the demonstrations. The tools you'll need are simple: netting, a sharp knife or scissors, twine, and the right size needle. A videotape can never be a substitute for hands-on training, and this program is intended primarily as a teaching aid for vessel operators and vocational schools like NetTech. It doesn't address all types of netting nor all repair problems, and you should consult your skipper, deck boss, or gear vendor for more specific advice. To begin with, concentrate on technique, not speed. Only hands-on experience can give you this kind of speed and skill. Netting is a flexible structure made of twines or filaments that are engineered into a system of knots, bends, and twists. The strength and efficiency of the structure depends upon the integrity of the individual meshes. Netting can be made by hand or by machines, which are capable of producing uniform products with high knot strength. The fabrication process begins with a raw material like polyethylene, which is colored with pigment, then extruded. Individual filaments are twisted into twines and wound on bobbins that can be woven into netting on automated looms. Two essential steps in the production of trawl netting are heat setting and depth stretching that apply heat and tension to set the knots with pressures of up to 100 tons. Traditionally, synthetic nets have been made from fibers like nylon or polyethylene. New construction methods like UC knotless netting and high-tech fibers like this high-strength polyethylene create nets that are unprecedented in terms of high strength, lightweight, and productivity. Good repairs can be made only with fibers that are compatible in terms of size, strength, and stretch. In general, repair twine should be the same diameter and made from the same material as the netting. Repairing torn webbing means retying each knot and restoring the original pattern of meshes. A well-executed repair should be essentially invisible. The basic procedure is to systematically trim the hole, then to sew it closed with a continuous twine. The key to good repair is maintaining the integrity of the meshes. When mesh sizes and shapes vary, and only a few twines carry the load, strength is compromised. But when the meshes are uniform in size and shape, each twine carries an equal load and strength is maximized. Small holes or damaged areas can be easily sewn by hand. For larger holes, it's advisable to sew in a patch of compatible netting. We'll cover this procedure later. Major damage can only be effectively repaired by a specialized repair facility that can remeasure the net and restore its original geometry. Netting is made of meshes. Each mesh consists of 4 bars. These bars are connected by 4 knots. A row of knots increases the depth of the netting by a half a mesh. Each knot has a bite. To determine the run of the netting, look at the bites. When they are oriented up and down, the netting is hung incorrectly for repair. When the bites run from side to side, the web is hung correctly for making repairs. Always look for the bites and make sure they run from side to side before starting a repair. Three cuts can be made in netting: a horizontal, a vertical, and a bar cut. Horizontal cuts leave pickups on the top or pickups on the bottom. Pickups can be cleaned to leave a continuous twine. Vertical cuts create siders. Siders can't be cleaned because they consist of 2 separate twines. A bar cut creates a 3-sided knot called a 3-bar, with 3 sides intact. It's essential that you be able to recognize 3 bars, siders, pickups on the bottom, and pickups on the top. Repair twine is held on needles. Start the twine on a round needle like this. Keep it under tension so it winds tightly. Wind a flat needle by turning it side to side. When you run out of twine, add another needle by joining the ends with a water knot. Lay the ends parallel to one another and use the end of one to make an overhand knot around the other. Now do the same with the other end. Pull the standing parts of each line so the knots slide together. If you've done it properly, the overhand knot should nestle tightly. Now watch it one more time. There are several ways to suspend a net so it can be mended. Use a bar, use a hook, or use a partner. To do a good job of mending, you need to work against tension. Suspend the net directly above the hole and be sure that the meshes holding the net lie in the same row. When the net is suspended correctly, downward tension creates an expanding triangle of stretched meshes. Inside the triangle, it's easy to control the size and shape of new meshes as they are created during repairs. Outside the triangle, mesh shape can't be controlled, and repairs won't produce good geometry.